Hi guys, welcome to one-dimensional graphs. Let's consider a straight line, okay, with a zero in the middle, arrows on each side, and numbering that goes 1, 2, positively to your right, and negatively to your left. Okay, this is a one-dimensional graph. Okay. So, if we were to say something is inclusive, okay, we would use a solid dot, okay, include, okay, and if something is open, okay, like this, it is not inclusive, okay. Now, let's consider an example such as, okay, minus 3 less than or equal to x, and x must be less than 4. Okay, you will be given something as follows, okay, and then you have to plot it on your one-dimensional graph. So, the minimum value here is minus 3, okay, minus 3. The maximum is 4, 3, 4. Okay, so I normally say take the minus 3, okay, let me use another color, okay, and bring down, okay, a vertical dotted line, okay, and 4, bring down a vertically dotted line. Next to, on the side, it doesn't matter left or right, okay, let's say I'm going to do it on this side, you say x, okay, and then you bring over a horizontal dotted line, okay. Now we know it's going to be plotted here and here, okay. Now we need to decide, is it inclusive or not inclusive, okay. That means it is inclusive. So inclusive is anything that looks like this or this, okay? Inclusive. Not inclusive, anything that looks like this, okay? Oh, it's inclusive, so a solid dot, okay? You color it in. Now, not inclusive, so open dot, okay? You can then connect your dots, and there is your graph. Now, give this an interval notation, okay? So x is an element, okay? When you have a inclusive or a solid dot, okay, you would use the block brackets. When you have not inclusive, you would use round brackets, okay? So inclusive, we know should be a block bracket. Minus 3. Okay? 4, okay, not inclusive, round bracket. Okay, so this was quite an easy example. Let's do another one to make sure you do get the whole concept of how it works. Okay, call it example 2. Okay, let's call it example 2, and it is 3 less than x less than or equal to 8. Okay, cool. So, plot a graph. 0. Minimum is 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay? 1, 3, 5, 7, and 8. I'm not numbering all of them, just some of them. Now, we said that you have to place your variable x on the side, okay? And now we bring down the numbers. First I'm going to bring over x with a horizontal line, okay? Then it's a 3, and it's an 8. 3 is not inclusive, so it's open. 8 is inclusive, so I'm coloring it in. I'm connecting them. There we go. So x must be an element Nope. Okay, that's inclusive, so like that. You can separate them by semicolon. 3, 8. And there you go. It's quite easy, it's not that hard. Hopefully you guys will be able to do something like this now. Let's consider a third example. We will now be moving in the direction of an and or. Hopefully you guys can understand that as well. It's not that complicated, but it does take a little bit of understanding. Okay, so this is the third example. Okay, and it is or okay, cool. Now, this is not as complicated as it looks. Let's draw a graph, okay? Minimum value, okay, is -3. So 1, 2, 3. -3, -2, -1, 0. Maximum 4, 4, 6. Okay, cool. 1, 2, 3, 4, 5, 6. Okay? Now, let's write our variable on this side. Okay? I'm going to show you guys, it doesn't matter where you write it, I'm going to write it on this side. Okay? But I'm going to give them a little distinguished number, 1 and 2. Okay? Okay? Now, let's bring over the numbers. -3. Okay? And 4. 1, 2, 3. That's number 4. Let's bring it down. Okay? Then we bring over x1 horizontally. Cool. There's an intersection. It's inclusive. It's not inclusive. Okay? Next one. 4. We've already brought it over. And 6. Let's bring 6 over. Our variable. Okay? Now, 4 inclusive. Yes. Solid dot. 6 not inclusive. Open dot. Okay? Connect your graphs. Now, or. Okay? Or means it can be here, or here, or here, or. Okay? It's everywhere it's allowed to be. Okay? So I'm going to write it down where it's allowed to be. It's allowed to be at -3, okay, -2, -1, 0, 1, 2, 3. It's not allowed at 4. Okay? Next graph. It's allowed at 4. It's allowed at 5. It's not allowed at 6. Okay? So you are allowed to go and write this now. X is an element of inclusive -3. Okay? Inclusive 5.
Powering on.
As follows, 5. Okay? That's where the OR operator is used. So it's OR here, or X might be here, or here, or here, or here, not here, but it's allowed here, so it's true. Or not here, so because it's not colored in. So this can be distinguished as follows. It's allowed at 4, even though this one says it's not allowed, it is allowed. Okay, that's why I did it in this way so you could see. I stopped here saying it's allowed at 3 but not at 4. Then I went to the next graph saying, oh, it is allowed at 4, allowed at 5, but not at 6. So you can go and write it as this in interval notation. It's allowed from -3 to 5, where all of it is inclusive. Or you can go and write this. X is an element of inclusive -3. Okay? It's allowed, not allowed. So let's write 6, open bracket. So either one of them will be valid. Okay? But I do prefer you guys use this one. So you use your whole range instead of just some of it. Okay? That's the OR operator, guys. Please do remember, it's allowed to be OR here, or. Okay? Now we will be doing the AND operator. Cool. So, once again, draw your graph. 0, minus 1, okay, because that's the minimum value, minus 1. The maximum is 7, so 1, 2, 3, 4, 5, 6, 7. Okay, let's get some more chalk. Now, we said that we are going to give them distinctive names, okay? So x1 and x2. Let's bring the variables over first, okay? Okay, now we brought our variables over. Let's bring the numbers use down, okay? 5, 4, okay, and 7. Okay, cool. For x1, we use not inclusive 1, so it's an open, okay, dot. Not inclusive 5, so it's an open dot. For x2, we used 4 inclusive and 7 inclusive, so inclusive 7, inclusive, okay, 4. Now, connect your graphs, okay, and now you have this. Now, and is the intersection of two graphs, okay? It's where they are both aligned, if you want to say it like that. We'll be looking at this part, okay? So, when looking at that, okay, that is where they are intersected, okay? But it's not allowed here, okay? It must be allowed. It must be allowed here, 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 and here. Then it is intersected. But it's allowed here and here. So 4 is in. Okay. 5. It's allowed here, but not here. So it's not included. Okay. 0. It's included here. Oh, it's not included for my second one, so it doesn't matter. So technically, okay, only 4. Okay, will be in our interval notation. So x is an element of 4 to 4, okay, or x is an element of inclusive 4, because 4 is allowed. 5 is part of the range, but it is not, okay, included. So 5 not included. Once again, I do prefer you guys use the second one, because then you use your whole range of the AND intersection. I hope you guys understand this. It's not that hard. I will be doing a fifth example. We'll be on the OR operator. Let's do it. Okay, it's the fifth example. Or 4. Cool. Now, let's draw a graph. Okay, our minimum value would be minus 1. 1, 2, 3, 4, 5, 6 is our max value. Okay, we have two variables, so let's give them distinctive names. Okay, x1 and x2. 2. Okay, let's bring our variables over. Please use a dotted line. Okay, bring your numbers over. 5, 4, and 6. Okay, cool. Now, for x1, it's inclusive minus 1, so let's color it in. For x1, it's non-inclusive 5, so leave it open. Then we are done with x1. Inclusive 4, inclusive 6. Inclusive 6, inclusive 4. Okay? Color it in. Connect them. Okay? Now, it's the OR operator. X can be here, or here, or here. Not here, but it is here, so it's allowed to be. So, it's allowed to be at minus 1. 0, 1, 2, 3. Okay? It's allowed to be at 4. It's not allowed at 5. Okay, but look now. It's allowed at 4. Okay, we got 4. It's allowed at 5. We add 5. It's allowed at 6. At 6. So technically, x is an element of inclusive minus 1 to 6 inclusive. And that would be your range for where the OR operator of x will be valid. Thank you for watching, guys. Please tune in for the next video.